This EV has traveled more than 70,000 miles over the past 8 years, and it still has the original brake pads with 8 to 10 millimeters of friction material on the backing plates. But the backing plates have significant signs of corrosion that could impact how the pads move in the caliper brackets. Going this far would be unimaginable for most internal combustion powered vehicles. So how did the EV do this? The reason is regenerative braking. When you hit the brake pedal on most internal combustion vehicles, hydraulic pressure is generated by the master cylinder and sent to the calipers. The hydraulic pressure causes the calipers to clamp down on the brake pads and rotor. This causes the brake pads to generate heat and friction to stop. Essentially, the brakes are transforming forward momentum into heat that is absorbed by the outside air. It also causes the brake pads and rotor to wear. On an EV, the regenerative braking system turns forward momentum into electrical power that is stored by the battery. When the driver hits the brakes to stop, let's say at a traffic light, the drive motor turns into a generator. The force required to turn the generator provides the stopping force. At this point, no hydraulic pressure is sent to the calipers, and the generated power is used to charge the battery. It's not until the last few miles per hour that the hydraulic brakes are engaged. When you also figure in the performance capabilities, weight, and silent operation of some EVs, using an economy brake pad is not an option for your customers or shop. Replacing the brake pads on an EV or hybrid is the same as replacing the brake pads on an internal combustion vehicle, but here are 4 things to remember. First, always remember to check the service information for the correct procedures to push back the caliper. Second, some EV brake systems have more sophisticated hydraulic systems upstream from the caliper. Not using the correct procedure may result in codes from the hydraulic control module or brake pedal simulator. Third, cleaning the caliper and bracket is critical for these long-lasting brake pads. Failure to service the surfaces will result in noise and, in some cases, uneven brake pad wear. Everything you learned servicing conventional hydraulic brakes still apply. Most calipers on an EV are a single or dual floating piston design. The hydraulic force generated by the caliper's piston is equalized between the 2 pads by the floating caliper body. For the caliper to float, the slides, guide pins, and hardware must not impede the movement of the caliper. Fourth, go for a test drive. Since the hydraulic brakes are used sparingly, bedding or burnishing the brake pads might be challenging. Some EVs will have a burnish mode accessible in the service menu or with a scan tool. What about pulsation, judder, and NVH? Technically, brake judder or a pedal pulsation is not an issue with a regenerative braking system. But all regenerative braking systems and conventional still use the pads and rotors to stop the vehicle at slow speeds when brake judder and pulsation is the most noticeable. Taking the time to measure lateral runout and disc thickness variation is still critical to prevent a comeback, no matter if the vehicle is a BEV, PHEV, HEV, or internal combustion powered. What about noise? According to J.D. Power, one of the leading causes of concern for vehicle owners during initial ownership is brake noise. For EVs, that's a challenge. Since there's not an engine to mask certain brake noise frequency, you need to use a high-quality brake pad designed for these applications and pull out all of your tricks to prevent brake noise. TRW's electric blue brake pads are the first full aftermarket brake pad line for EVs and hybrids. TRW Electric Blue's design and friction formulation achieves a noise, vibration, and harshness score of over 9 out of 10, exceeding the OE NVH specification of 7 out of 10. To make installation easier, the pads come with applicable hardware like abutment clips and have shim technology that matches the OE design. With the new copper-free formulation, the TRW friction line has outperformed itself in categories of comfort and lifespan. Reduced noise and dust have brought TRW ahead of competitors, putting the product lines ahead in the California copper-free legislation deadline of this year and reaching above the standard of OE. TRW is currently the only brand, with all lines being entirely copper-free.